I wanted to start off with this architecture diagram that shows where we are right now at Albert Einstein, and where the integration lies. Right? So there's a legend in the upper right-hand corner that shows the type of connection that's being made. So that might be a technical detail that's not super important to you. That's fine. But basically, what we have on the left side is ParallelWorks Activate, and on the right side is the sort of the cluster, if you will, or like the login node and the worker nodes on the cluster. And all of that, you can see there's a big dashed line around everything. All of that is within the Einstein College of Medicine data center. And so ParallelWorks Activate has, a front end where there's a user interface, a web page that can be viewed, authentication mechanisms. But really from the user experience, what's really exciting is the user workspace, right? So every user is provisioned their own containerized workspace. You can view it as sort of like a shell in the cloud, or like a place where you can enter commands, right? But it's sitting there as part of the platform. And right now, that containerized workspace has the same, is mounted to the same high performance file system as the cluster. So that means that a user can see their files in their workspace just as they would see their files if they're on the head node or a login node or on a worker node on the cluster. So it provides for very easy access. And what we're really excited about doing is going, when we mentioned the sort of one step further and enabling scaling by basically replacing the login nodes, those personal login nodes, with the containerized user workspace, is this second diagram, where the user workspace through Activate is the login node. It is the coordination place that users are launching their jobs and calling up the worker nodes to do their work. And then that way, it actually kind of reduces a little bit of resource usage. But also, because these are containerized workspaces, they can scale up and down really elastically. So, and again, all of this is within the on-premises data center. The next two slides that I wanted to show are kind of two additional, if you will, almost like generalizations, right? When we discussed running, we talked about how to put the on-premise systems side by side with cloud systems, right? So we're going to add a cloud cluster to this. And that's what the following slide is. So here, the idea is to show the ParallelWorks Activate platform as is connecting to both two clusters. On the top is a cloud cluster, and on the bottom is an on-premise cluster. And so this is a system diagram that shows our commercial shared tenancy platform. So so you can see the boxes are separate. So the platform itself is in its own network, if you will, its own kind of working space. Whereas the cloud cluster that's attached to it has its own box around it, as does the on-premise system, right? They're kind of separate from each other. Just to note that if we were to implement, when we implement this at Einstein, the on-premise box would be connected to the SaaS box, the platform box. Those two boxes would remain connected. But for the most general case, where a new customer might arrive or may already have resources scattered across multiple data centers and across multiple clouds, it's possible to connect resources that are across disparate sites to one single place.
Which I think is really valuable, Stefan. So could you just, I don't mean to interfere with the workflow, but I can envision that people might be thinking this right now. And if you could just speak really briefly about this. In the case of the cloud cluster, how do data get to the worker nodes? Like, how is that managed?
Sure. So the cloud cluster itself is provisioned within a single virtual private cloud, like a single network, if you will, like you carve out a part of the data center. And so the worker nodes and the head node are all in that one place, and they're connected to each other through high-speed networking fabrics. And it depends from cloud service provider to cloud service provider. They have slightly different, dramatically different frameworks. But the point is that we can leverage those really high-speed interconnects to achieve the same kind of performance that you would see on-premise, but within a cloud data center. And it requires a little bit of tuning to make it work. But at the end of the day, it's the performance is very comparable. So moving the data around within the cluster is actually pretty easy because it's all within the same space, the same network. What becomes a little bit more challenging is moving from site to site, from across data centers, across clouds, moving on-premise to cloud, that kind of thing. And so there we often use an intermediary a data transfer mechanism, whether it's something like, it could be as simple as copying data to a bucket, a cloud bucket, and then accessing that bucket from a variety of different places, which I can show during the demo.
Yep.
But there are also more sophisticated approaches like various global namespace products and other data managing or data planes, if you will, that can be integrated to facilitate the data transfer. But those bring greater performance, but with additional setup complexity.
Yeah, fascinating. Thank you.
The last architecture schematic that I wanted to show, which is relevant because we mentioned like a highly secure environment for working with personal information and protected information. Recent news for ParallelWorks is that we've achieved, or we have this high security platform that is at the IL5 level. And what it does is it basically takes the general commercial offering that we have. So I'll flip back and forth between the slides, and you'll see that I've basically just literally shrunk and moved the Slurm cluster and the platform back and forth with each other. Mm-hmm. So what we've done is we've taken the cloud aspects, so that would be the platform and the cloud clusters, and we've wrapped them within a secure cloud environment that has special controls to satisfy the needs of an IL5 environment. And that includes a whole series of things involving networking, authentication, security, logging, monitoring. And so you can view it as sort of like a wall that gets built around it to make it to bring it up to a highly secure environment for certain kinds of workloads. And so this is particularly applicable for government applications. But you can still connect on-premise systems to it and various cloud service providers.